Hello, this is day 2 of solving trig equations. These problems will be a little bit more complicated. Before we talk about solving trig equations, I wanted to review quadratics. Now, this will help us in some of the problems that we will deal with later on in the lesson. So when you're solving quadratics, each quadratic is different, and so you have to really look at the problem and determine which strategy you're going to use. So this one, as you can see, there's only 2 terms. You do have the quadratic, it's squared. This one, again, there's a quadratic, it's squared, but there's 3 terms, so that they're different setups, right? They look different, therefore the way we're going to solve them is different. Now, please note they're both equal to 0, which is important when you solve for quadratics. So this one, because there's no C term, right? This is your C. Then I have a common term, a common factor. So this both has X. So this one, I can factor out an X. So this will give me 2 solutions and 2 things. So we said each part X equals 0. So I have 2 solutions, X equals 0 and X equals -3. So if you put them both into the original equation, it will equal 0. Now for the second one, it's different. I can't pull out or factor out a common factor because there's nothing that's in common. This one is now an integer and not just I have an X and X. So I have 3 terms as opposed to here had 2. So this one's different. So I'm going to try to straight factor that. So the factors of X are X and X. The factors -2 are 2 and 1. Now this middle term tells me plus. So the bigger the 2, so it's plus minus my operation. So it tells me that these 2 signs here, one will be positive and one will be negative. The plus here tells me that the bigger number 2 has that same sign as positive. So in both problems we're factoring, just the factoring is different. Here it's GCF. Here it's binomials. 2 binomials. Okay. All right, so let's look at these. So solving a trig equation. Now, what's different than the ones previous that we've done? Well, these are quadratics. You can see that it has a square. Now, our beginning steps are still the same. We need to isolate that. That's where the variable is contained, so you need to isolate that. So this is really similar to 4x minus 3, right? Well, similar to that. Similar idea, right? So you would add 3 and divide by 4. It is the same thing for this. So I'm going to add 3, and then I'm going to divide by 4. Now, for here, because I just have just cosine squared, to undo a squared, we're going to, now remember, this can be written, it's the same thing as this. We just write it differently, but it's the same thing. So you're going to take the square root of both sides. So I'm going to have cosine theta equals the square root of 3 over 2. Now, because you took the square root, it is a plus or minus. Now, because it's a plus or minus, when we do the inverse, oops. I'm going to do the inverse. So we're going to here, that can mean then all 4 quadrants. cosine is positive here and here, it's negative here and here, but that means I'm going to have 4 answers and not just 2 because we have plus and minus. So I'm looking over here. So my cosine is adjacent over hypotenuse. So that tells me this is going to be 30 degrees. Okay. So they're all going to be 30. So for every 30 degrees reference all the way around, that would be, so here, that's going to be pi over 6. And this one is going to be 5 pi over 6. This quadrant, third quadrant, that would be 7 pi over 6. And then the fourth quadrant will be 11 pi over 6. Now let's look at this one. This one is different. This one, again, I have a squared, so it's a quadratic. But I have a sine squared here and a sine squared. So can I factor out the sine? Well, yes, you can. So I'm going to factor that out just like we did earlier in the review problem. So these problems are all going to be different. You just have to look at them and decide what you're going to do. Okay, minus 4. Okay, so I'm looking there. So I have 2 different things. So this one's going to be equal to 0. Oops. So that's one solution. And then we have a second one. Okay, so this one, sine is equal to 0. Well, where is that? Sine equals 0 in 2 places, here and here. So I'm going to have 2 answers. So that's going to be theta is going to be equal to 0 and pi. Now over here, I'm going to add 4, and then I'm going to do the inverse sine. Now, we know that can sine of some angle equal 4? Can the range be 4? The answer is no. So this one has no solutions. And this one. So my solutions are here. All right. Okay. So again, I see that this is a quadratic. But this time I have cosine, not squared, and then something. Doesn't that kind of look like a quadratic? Doesn't that look like 2x squared minus x minus 1? Yes, it is. So I'm going to do something called substitution. I'm going to let x equals cosine theta. So I'm going to do this and factor that. Okay. Sometimes that's easier. You can substitute. So I'm just going to factor using x. So the factors of 2x squared is 2x and x. The factors of -1 are 1 and 1. So I just have to figure out where that negative is going to go. So because the middle term is negative, that means the bigger number, 2, needs to be negative. But you don't put it here, because this is going to be positive. But it gets multiplied to this one at the end. So that one's going to be negative, and this is going to be positive. So this is going to get a -2, and this is going to get a positive, a -2x here, and plus a positive 1x. And that's going to give me a -x. Okay. So we are going to continue. So x equals -1/2, and x equals 1. Now, We aren't done because we're really doing cosine, but now I'm going to substitute back. So I know x equals cosine, so I can say cosine of theta equals -half, and cosine equals -1. So I'm just substituting, right? Putting that back. And cosine. Now for this one, a half, that's going to be in 2 quadrants, right? Where cosine is negative. Cosine is negative in the second and third quadrant. So if -half is here, what angle is going to be that? That's going to be 60. So 60 would give me, that's 3 in the denominator. So that's going to be 2 pi over 3. And the next one's going to be 4 pi over 3. 2 pi over 3 is going to be in the second quadrant. 4 pi over 3 is going to be in the third quadrant. Cosine of -1, that's only one place. It's special. It's here. So that's going to be pi. So this one has 3 answers. All right. Let's look at this next one. One's different, right? It's different because I have sine and cosine, which is different. Okay, so let me just do the math and distribute, because I'm going to say that's probably the same. But I don't want sine and then cosine, so I want it all to be the same. This is where we're going to use an identity. So I remember that sine squared theta plus cosine squared theta equals 1. So if I solve for cosine squared theta, that equals 1 minus sine squared theta. So now I'm going to substitute this for that. Now when I do that, what happens? Now I have all sine, and that's what I want. I want everything to be sine. I don't want 2 different functions in an equation. So I'm going to move everything to the left because you still want it to equal 0. So I'm going to have sine squared theta plus 4 sine theta. Okay, minus 1, that's going to be plus 3 equals 0. Okay, what I'm going to do, you can put it over here, I'm going to substitute again because I think that's going to be easier for you guys. So I'm going to let x equal sine squared. Oops, sine theta. So I'm going to put here x squared plus 4x plus 3. I'm going to factor x. What am I? So it's plus plus. It's going to be plus plus. What are the factors of 3? Well, there's only one pair, 3 and 1. Right? So this is going to be x equals -3, x equals -1. Okay, and then I'm going to substitute that back in. So x is going to be sine theta equals -3, sine theta equals -1. Okay, so if I'm looking here, I know I need to do the inverse, but sometimes if you're looking at it, you can just think about it. Like, sine of what is going to give me -3? Well, we know that the range of sine is between -1 and 1, so this is not possible. This is another not possible. So there's no solutions. No solutions for this one. Okay. So I can deal with that one. So over here, when is sine -1? Okay, so let me think about that. So in inverse sine of -1. Well, there's only one, and I believe it's here. It's this point. Remember, it's the y value, 0, -1. And that is 3 pi over 2. That's 270. There we are. So very different than our previous lesson. So I can have 2 answers, I can 3 answers, 1 answer. All right, let's do one more. Ooh, tangent. Okay, so tangent, everything's in tangent. So that I don't have to use an identity. So for here, though, this is, I hate squared being negative. So I'm going to move everything this way. Because it needs to be 0 because it's the squared. So tangent squared 0 plus 2 tangent theta. Subtract the 5s. That's going to be plus 1. So I'm going to substitute x equals tangent theta. So I'm going to have x squared plus 2x plus 1. That's nice, right? I was going to say that's not so bad. So factors of 1 are 1 and plus plus. So my answer is x, oops, it is 0, my bad. X equals -1. All right, so now I'm going to substitute that back in. So it's tangent theta equals -1. So when is the angle or tangent -1? What angle is going to give me that? Okay. So I know tangent, usually it's 45, right? Tangent 45 or pi over 4 is 1. But I want a -1, so I have to think, where's tangent going to be negative? So all students take a calculus. So it's +1. So it's going to be here and here. Right? So this is 45. This is 45. So this is going to be 3 pi over 4. And the fourth quadrant is 7 pi over 4. All right, so here are problems on your own, practice on your own. So double check, just really look at it, the whole thing. And then notice if you have 2 different functions. So if you have 2 different functions in one equation, you should use an identity. All right. Thanks for watching. Bye.